So in our discussion, we're looking at stoichiometry or chemical calculations that you're going to be finding in chemistry. So I want to introduce you to some few terminologies you're going to be using: relative atomic mass, given the symbol AR, and sometimes written as RAM, relative atomic mass. Now, each time you hear of the word relative atomic mass, it refers to an element. So the elements that you find on your periodic table, when we talk about the relative atomic mass, so this is what we are talking about. So now, what exactly is the relative atomic mass? Well, the relative atomic mass of an element is, we can say, is the mass of one atom. So it's the mass of one atom of an element, compared, to 1/12, the mass of pure carbon 12. So that is what we mean. So the relative atomic mass of an element is simply the mass of one atom of that element, and you compare it with 1/12, the mass of carbon 12. Now, basically speaking, if you look at, you compare 1 with 1/12 multiplied by the mass of carbon 12, which is a 12. If you look at that, it will still give you a 1. So it's like you're comparing, something, to 1. That's what we mean. It will give you that something that you're talking about. And that is why, if in reality, if we look at the relative atomic mass of some elements, for example, elements such as hydrogen, it only has the relative atomic mass is simply 1. For carbon, the relative atomic mass is 6. For oxygen, the relative atomic mass is just 8. So that is what we mean. So when you go on the periodic table, if you look at the nucleate notation, you are going to find that this is the atomic symbol. So this is what we call as being the atomic symbol. And at the bottom there, you have what we call as being the proton number, sometimes called the atomic number. And on top, you have what we call as being the relative atomic mass, sometimes known as the nuclear number. You are going to understand that later on. So now, when you go on your periodic table, you just pick up the highest number that you have on top there. That is what we call the relative atomic mass. So it's the mass of one atom of an element compared to 1/12 the mass of pure carbon 12. So that is what we mean. For example, if you look at aluminium, aluminium has 13 and 27. So the AR of aluminium is simply 27. If you look at things like maybe calcium Ca, it has got 20 and 40. So the number on top there, that is what we call as being the relative atomic mass. So you shouldn't be struggling when it comes to the relative atomic mass. Another terminology that I want to introduce to you, that you are going to look at, that we are going to be using, is what we call as being the relative molecular mass. In most cases, when it comes to the relative molecular mass, the symbol that I love to use is Mr., but in some may use what they call as being RMM, because they are talking about the relative molecular mass. That's fine. But what exactly is the relative molecular mass? Well, the relative molecular mass, each time you hear of that, it can refer to a compound. In most cases, when we talk about relative atomic mass, it has to do with a compound. That is what we mean. So the relative molecular mass is simply, we can say, is the sum of the relative atomic masses, the sum of the relative atomic masses over the elements in one molecule of a compound. So that is what we can refer to as being the Mr. So it is the sum of the relative atomic masses of the elements in one molecule of a compound. So that is what we mean. So what am I trying to say here, or how are we talking about there? So I'm simply saying for the relative molecular mass, it is simply the sum of the relative atomic masses of all the elements in one molecule of a compound. For example, you might have a compound we are calling as being carbon dioxide. So when you look at the mass of this one plus the mass of that one, you combine them, that creates what we call as being the relative atomic mass. So for example, you can talk about there's oxygen and there's also carbon. So how many oxygen atoms are there? It is 2 multiplied by the relative atomic mass of carbon, which is simply 16, so that will give you a 32. Carbon is only 1 multiplied by the relative atomic mass of carbon, which is 12, so that will give you 12. So when you add now that, so you simply add that, so when you add that, that is going to give you 44. So meaning that is simply the mixture of carbon dioxide. Let me show you some further examples that maybe we can talk about. Imagine I simply tell you to say let's put up maybe a few examples there so that you can actually get to appreciate. So just a few examples there that I can give you. So the question that I want to give you says calculate. So calculate the relative molecular mass of the following. So calculate the relative molecular mass of the following. A, we do have what we call as being methane. B, we have calcium hydroxide. Then C, we have what we are calling as being aluminium sulfate there. Then D, I can maybe give you a hydrate there. Maybe I can say you have got copper 2 sulfate 5 water. So we want to calculate the relative molecular mass. Now I want you to be clear that when it comes to the relative molecular mass, this relative molecular mass sometimes is also known as being the relative formula. They call it as being the relative formula mass. So you may find the word in place of relative molecular mass, you may find relative formula mass. It is just one and the same. So now if you look at the first one there that we do have there, they have given us methane. There are so many methods. I believe people find it easier like this to isolate the elements that are there. So there's hydrogen and carbon, but how many hydrogens are there? There are 4 multiplied by the relative atomic mass, which is 1. Please, you can check that on your periodic table. Carbon is simply 1 multiplied by the relative atomic mass of carbon, which is 12. So that would be 1 times 12 will give us 12. Then you add, that gives you the mixture, which is going to be a 16 there. All right, so remember the relative molecular mass has got no units, so normally we don't write the units there. What about when I talk about calcium hydroxide? Well, if you want, for simplicity's sake, what I can advise you if you are struggling like that, remember if the number is outside, it means it is multiplying what is inside of the brackets. So you can multiply here, there's a 1 and there's a 1 which we don't write. So it would be like Ca, there's a 1 here and there's 1. 2 times 1 will give us O2. 2 times 1 will give us H2. Then you can work them out there. So how is that going to be? So let me just use the space that is here. So we have Ca, O2, then H2, because I've actually expanded that. So there's hydrogen, there's oxygen, and there's calcium. So how many hydrogen? 2 times the atomic mass, which is 1, will give you a 2. How many oxygen? 2 times the atomic mass of oxygen, which is 16, will give you a 32. Then that is calcium, it's 1 times the atomic mass, which is 40, so which will give you 40. So the next step that you need to do is simply to add that. So if you use your calculator, 2 plus 32 plus 40 there, that is going to give you 74. So that is the mixture in this case of calcium hydroxide. All right, what about the other one that we have in there? Let's try to check that one out as well. let's try to check that one out. So for the C part, we have got aluminium, sulfate. Again, like I said, if you are struggling, you can first of all the brackets there, and if there's a number outside means you multiply. So you can have aluminium, then 2, there's a 1 here, so it is going to be S3. Then now when you look at your oxygen, it will be 3 times 4, so you are going to have O12. So you have got oxygen, you have got sulfur, and you have aluminium. So now you can simply try to work them out. So how many oxygens are there? There are 12 multiplied by the atomic mass of oxygen in this case, which is 16. So yeah, 12 times 16, that is going to give us a 192. All right. Another thing that you are going to have there is sulfur. So if you go on the periodic table and you look at sulfur is actually sulfur is actually a 32. So that is going to give us 32 multiplied by 3. So if you look at 32 multiplied by 3, that will give you a 96. Then aluminium, there are only 2 atoms of aluminium multiplied by the atomic mass, which is 27. So 2 multiplied by 27, that will give us a 54. So you can add now that 192 plus 96 plus 54, and that is going to give you a 342. So this is the relative molecular mass, sometimes called the relative formula mass. Well, let's conclude and actually look at the other one. You have got anhydride. This is what we call copper 2 sulfate pentahydrate, or if you want you can say 5 water, that is fine. So if you look at copper 2 sulfate dot, that shows the separation of the water molecule incorporated. Now what you can do here, you can treat the water as 1. That's the easiest. Now if you look at just H2O, the mist of water, it's 1 times 16, which will give you a 16. For hydrogen, there are 2 atoms times 1, which will give you a 2. So for H2O alone, water, it has got a mist of 18. Now here, the water can be treated as 1. But how many H2O do you have? You have got 5. So you can say 5 multiplied by 18. That's the simplest that you can do. So it will be 5 times 18. That is going to give you a 90. Then you can come here. You have got this oxygen from the compound there. So you have that oxygen. You have that sulfur, and you have got the copper there. So how many oxygen are there? There are 4 multiplied by 16, which will give us a 64. Sulfur, it is going to be 1 multiplied by 32, which will give us a 32. Copper is only 1 multiplied by the atomic mass, which is 64, to give you 64. So now when you add all that, what is it going to give us when we add all that? Well, when we add all that, you are going to have 90 plus 64 plus 32 plus 64. So this is going to give you a 250. So that is the mist that you're having. Remember, it has got no unit. So you can do a lot. You can actually look at a lot and actually practice. Probably in your own spare time, you can find, you can work out this. You can find the relative formula mass of maybe what we are calling as being ammonium carbonate. So you can do this one in your own free time, ammonium carbonate. You can also look at sodium sulfate, and you can look at let's say 3 calcium phosphate. So you can look at calcium phosphate, and so on and so forth. Then maybe you can look at hydrochloric acid. So that is what you can look at. Try to calculate the mist and see if you're able to do it. Thank you so much for watching my video.